Hello, everyone. In this session, we're focusing on system boot and boot in Linux operating system. As you can see, we have here a different part of the operating system. So when, for example, we have a BIOS, you know about the BIOS that's located in uh, part of your hardware. So you can load your BIOS and change some configuration of your hardware, like timing, first boot, and some stuff like that. So when the BIOS boots, it will execute the MBR. And MBR actually is a tiny part of your uh, partition. So it's like 512 bytes. So I'm going to explain in the next slide. But it's like a very tiny one that's around 512 bytes, and it will execute grub. So you see that MBR will execute the grub, and grub actually is something that you see. For example, you have seen that sometimes when you have a two operating system, you select one of the operating system uh, from your boot menu. So that one is the grub, and then grub execute the kernel of the operating system, and kernel will execute the init, and init execute the run levels program that I'm going to explain about run levels and how does it work. And then we have program is going to be executed by run level under etc rcd. So this is MBR. So it is like 512 bytes, and we call that one as a master boot record. Most of the modern operating system, when we are talking modern PCs, like current PCs that we have, they don't have like some of them they don't support MBR. They just have GUID. That one actually is most modern. It has a graphic, and then um, it supports many partitions on hard drive. Uh, so there are some drawbacks for MBR. One of those drawbacks are like limitation of the hard drives that you can assign to MBR, and the partitions that you can assign. So then with the new uh, structure of the boots and master boot records, and then you can have more partitions. So this is like the structure that we have. Uh, that's bootloader that contains 440 bytes, and then this signature it includes 4 bytes, and then your 4 partition table, partition 1, 2, 3, 4, each of them 16 bytes. And then you have MBR signature, which is 2 bytes. So totally, this number is going to be 512 bytes, which contain the master boot record. So after master boot record loads that one, execute the grub. So master boot record execute the grub. Actually, grub is like that. So you see, sometimes you have options to select. Sometimes you have different options, different operating system that you can select from here and then load that operating system. Once you select, for example, one of these options, then it will load the kernel of that operating system. So then we reach to run levels. Basically, operating system, they have different run levels between 0 to 6. You see that 0 is halt. 1 is single user mode. 2 is multi-user. And then 3 is full multi-user mode. 4 is unused. X11, which is the graphic, is number 5. And reboot is run level number 6. So the thing is that if you want to show you, for example, which run level you are, you can go to your Ubuntu and just type run level. And then you see that you are now currently on a run level number 5. Okay. Um, Run level has been changed so many times. Like we were talking about run level, like goes back to system V that we had many years ago. And most of a modern operating system currently is based on the system D. And the thing is that when you're comparing these commands together, like um, there are different commands for system V and system upstart, like Ubuntu's, and system D, which is similar to Fedora. So like when you're typing, when we wanted in the past restart some services, we were using this command under system V, etc init.d. This is H, for example. This is the name of a service that you're starting or restarting. Under upstart, we are using service like that, service SSH start. Currently, most of operating systems support upstart, but system V is completely obsolete. System D also is the new way of um, reaching to the services. You're using systemctl, and then you type start, restart. We have also stop, status, and then the name of a service. To show you, for example, if I want to change my run level, I can type here system CTL. For example, if let me show you that service also works here. If I type here service SSH status, let's see that. You see the SSH is running, right? I can type here system CTL, um, then status SSH. So that's like system V. Sorry, this is like system D, and this is like upstart that we are running. But you see that the result is the same. We don't have any changes in the output. Okay, let's talk about this way now. If I want to change systemctl, isolate the multi-user dash user and then target. So this one, it will change the graphic mode to like a command line. So it will isolate that one. So that means that we are now switching to um, like operating system without graphic. So systemctl, if you log in here now, Ubuntu and Ubuntu. So sudo dash s, and if I type here systemctl get default, that shows me graphical target, and then I can systemctl do set default as graphical target. And then I can reboot that operating system. Okay, so then my operating system should boot through the graphic like that. So isolated will change that one to without graphic, and then you can change it to set the default as a graphic mode. So this way we are shifting between run levels. The run levels that I show you, like some of them they support single user, some of them they support multi-user, and like graphic X11 is part of that. Also, it's a good idea to talk about the partitions also here. So you know that when you are partitioning your hard drive, so basically part of that is going to be part of operating system. So that's like a logical partition that we have in the hard drive. So you see that, for example, this one, SDA1. So this SDA is part of that, like we have here 1, 2, 3, 4, 5 partition. And this is one single hard drive, like is a disk 0, for example. And you see that this disk, it has 931, around 1 terabyte, right? It's a 1 terabyte disk. So the main path is dev SDA. So if you're adding another hard drive, it's going to be SDB, right? And the third hard drive is going to be SDC. So it is like that. Mounting the hard drive is going to be like that. So then, like, if we focus on the first hard drive, then you have SDA1, SDA2, SDA3, SDA4, and SDA5. Most of a file system in Linux operating system is ext4, ext3 is a common one. ext4 is the latest version, so that it has a journaling. That means that you can recover your partition if something bad happens. And how we can see this partition in my Linux operating system, I'm going to show you. There is a command that we can do it with ls blk that shows that your partition like that. And also there is a partition, we call that one swap. And swap actually is a partition which is used as a virtual memory. And like if you have a 2 gig RAM, for example, 2 gig RAM, and you're thinking that, okay, 2 gig RAM is not enough for loading most of the software, then you can add swap partition. And swap partition is in Windows operating system is a paging. So usually the swap partition is equal to uh, 2 times of your physical RAM. For example, if you have a 2 gig RAM, then we assign usually 4 gig to swap partition. But this is like an estimate that we are doing. It depends on the system that we are using. So then if the programs, if like a we need a lots of RAM, then that program, it can use that swap partition as a RAM and as a virtual memory. So it happens that sometimes you plug in your USB drive and you want to see that USB is listed under this partition, and usually df-h, it shows the list of that mount drives that we have. Let's come back to our operating system. So let me show you first this operating system like LSBLK. So it shows me that SDA and SDA1, SDA2, SDA3. So you see how I have also swap partition here. Okay, so the main SDA3, it has 500 gig, around 500 gig. If you want to show like what mount points you have, you can use df-h. That's a human readable. H lowercase is showing you like this, df-h. So if you compare this one, so it's more readable, the first one, -h. So here also you can see that I have mapper here, and this device SDA2 is connected, so that boots the EFI. And if you have like USB stick which is connected to your operating system, then you can list it here. You should be able to see that USB under here. This command also 3 slash dash L1. I have to install 3 apt-get install tree. So then under here, you see that, for example, is in tree view. So that's like a root that we have. And you see that I only showing the first level after root. So this bin, it has this folder. You see that the most of folder, important folder are listed here. And the last part that I want to talk is about LVM, which is called Logical Volume Management. Is a form of a storage virtualization that gives you more flexible approach. Here, like we are having different disks, and we can have like one um, integrated disk as a primary, and then you can split that disk in different partition like physical volumes. And if something happens, so then you can recover it better. So this is like one of the approach that we have for LVM, and is like chunking the physical disk is going to be easier when you're using LVM. So basically, if I want to show you something, is like this picture that we have different file systems, different logical volume that we have, and then you create a volume group, and under volume group you have a physical volume for each of them. And then here also showing that how it works with the file system and logical volume. So you see that we have here SDA, which is part of your first hard drive, and this is like as part of your second hard drive. So this way you can integrate 2 or 3 physical disks that you have, and then create a one LVM, and then split that LVM in different physical partitions. Basically, that concludes on this session, and I hope this has been informative, and thanks for watching.